Good afternoon, one and all. I am Dr. Radhika Deshmukh, Assistant Professor, Shri Shivaji Science College, Amravati. I am going to present here research article on gravitational waves and cosmic domain walls. Under this heading, the outline of this research paper is Abstract, Introduction, Domain Walls and Cosmology, Gravitational Waves from Domain Walls, Conclusion and References. In the abstract, in this paper, we discuss the cosmological constraints on long-lived domain walls and cosmological scenario with stable domain walls are formed in the early universe and that produces a significant amount of gravitational waves. We review possible extensions of the standard model of particle physics that predict the formation of unstable domain walls and can be proved by observation of like gravitational waves. It is shown that recent results of pulsar timing arrays and direct detection experiments partially exclude the relevant parameter space, and that a much wider parameter space can be covered by the next generation of gravitational wave observatories. These are the gravitational waves in the universe. In introductory part, the progress of direct observation of gravitational waves is bringing about drastic developments in the astrophysics and cosmology. Experimental sensitivities for the direct detection of gravitational waves have been improved substantially during the past decades, and many new gravitational wave observatories are planned to be built in the world. In this paper, various possible sources of gravitational waves and clarifying so that extent various cosmological sources of relic gravitational waves are to be discussed in this literature. For that, this one is a metric which we use. Let us consider the following model of real scalar field phi. Equation 1 is that model. V of phi has degenerate minima. It is a potential having two degenerate minima at phi is equal to plus minus v. In this theory, there is a discrete z square symmetry under which the field transform as phi to minus phi. Domain walls are produced around the boundary of these two domains. Consider a static planar domain wall configuration lying perpendicular to the z-axis in the Minkowski space, that is phi is equal to phi of z, solving the field equation d square phi by dz square minus dv by d phi is equal to 0, equation number 3. Later on, we apply the condition z tends to plus minus infinity and it rapidly changes around 0. That is given by equation number 4. The energy momentum tensor for the static solution is also given here. If we consider a planar wall orthogonal to z-axis, A is equal to A of z, the solution of classical field equation reads, and that is given by equation number 8. Configuration interpolates between two vacua and that one is given by equation 9. After solving that 10 and 11, as we have seen in above two examples, the properties of domain walls can be characterized by two model dependent quantities, the tension sigma and the thickness delta. In general, the wall thickness is roughly given by Compton wavelength of field which causes the spontaneous breaking of discrete symmetry, while the tension is estimated in terms of height of potential energy separating the degenerate minima. In the following, we do not specify the magnitude of sigma and provide some model independent arguments about the evaluation of domain walls. The properties of domain walls can be characterized by two model dependent quantities, the tension sigma and thickness delta. In general, the wall thickness is roughly given by Compton wavelength of the field which cause spontaneous breaking of discrete symmetry, while tension is estimated in terms of height of potential energy separating the degenerate minima. The spectrum of gravitational waves for 5 different cosmological conformal time that is given as in this graph. From that graph, one can estimate the spectrum of gravitational wave produced by them. It is represented in graph where Sk represents the spectrum of gravitational waves per unit logarithmic frequency interval. It can be shown the amplitude of gravitational waves produced by domain walls in the friction dominated regime is much smaller than produced in the scaling regime. Various well-motivated particle physics models predict the formation of unstable domain walls in the early universe, and it is possible to probe such models by observing gravitational waves produced by them. The signatures of gravitational waves can be characterized by two quantities, the tension domain walls and the temperature at the annihilation. From this paper, we conclude that however it is difficult to estimate the spectrum of gravitational waves accurately over broad frequency ranges due to limitations of dynamical ranges simulations. In order to resolve this difficulty, it will be necessary to develop some alternative method to compute the spectrum of gravitational waves analytically. In order to resolve this difficulty, it will be necessary to develop some alternative method, and that's one is such approach would enable us to estimate the signature of gravitational waves more. The search for cosmological gravitational waves will have a great impact on the spectrum of gravitational waves and that distinguish different models and high energy physics and cosmology. The collapse of domain walls will provide a possible way to interrupt the results of forthcoming gravitational experiments. Even if there is no evidence of signals, such information can be used to constrain various particle physics models beyond the SM. These are the references. Thank you.